We will again be working with our linked list of points, but this time we want to move the linking part of the list into a function. So as before, we have our structure point declared with an x coordinate, a y coordinate, and then a component that stores the next element of the linked list. We have our function print points from our previous example, and then in our main function we have the 3 points declared and a pointer to the beginning of the list, which we initialized as the address of pt1, and then we linked the list, we linked the address of pt2 by putting it into the next component of pt1, and so forth. And that's the part we want to automate. So we will need to retain the start of the list in our main function, because somewhere someone needs to keep track of that. But now we want to write a function append that links the list together. So I want to pass to this append function pt1 and pt2 somehow. So ideally, this is something like this, pt1, pt2. I want to append to pt1, pt2. But that wouldn't work because then copies of pt1 and pt2 would be passed to the append function, and any linking there would be happening with the copies and not with the actual points that I have declared here in my main function. So I need to pass the address of pt1 to the append function and the address of pt2 because that's what I really want to write in there. So I want the address of pt2 put into the next component of pt1. I can't be dealing with a copy of pt1 because then the next component of the copy would be modified, but not pt1 itself. All right. So I want to append to the pt1, pt2, and I also want to append to pt2, pt3. So I need to pass the address of pt3 here. So these two lines are now no longer necessary because that's what my append function is going to do. So let's write that function. So the append function is currently such that it doesn't return anything. So I'm going to give it the return type void, and I pass into it 2 pointers that point to a struct point. The first one is the one that's being appended to, and the second one is the one that's being appended. So I'll call the first one end, assuming this is the end of the list, and the next one I'll call new, because that's the new element I want to append to the list. And how do I do that? I need to go to the point that end is pointing to and go to its next component. Since end is now a pointer to a point, I need to use the arrow. I need to dereference first and then go to the next component. And I need to fill that next component with my new pointer, new pt. And that's all the append function does. Next, I need to take this and make this a prototype. So I'll put that prototype right here, with the semicolon behind it, and we're good to go. Let's take a look at what happens. So first, my 3 points are declared as before. They're initialized. My start pointer is declared and then initialized with the address of pt1. If I look at my memory visualization, the address of pt1 is fff4, and indeed that's what shows up in start. Next, append is called, and I pass to it the address of pt1 and the address of pt2. The address of pt1 is fff4. The address of pt2 is ffE8. So those are the only things that my append function will know. Here you can see the append function. It only knows fff4, the current end of the list, and the new pointer ffE8. And it's going to go to fff4, to the structure that's stored there, to its next component, and put new pt into that. So fff4 is obviously where pt1 is stored. We knew that. And so watch what happens to pt1.next. We're going to fill that with ffE8, which is what was stored in my new ptr. Next, append is called again, but this time with the address of pt2 and the address of pt3. pt2 lives at ffE8, pt3 lives at ffdd, and so watch what happens. There it is. ffE8 and ffdc are passed into the append function, and again it does its magic and puts the new pointer into pt2.next. Now my list is linked together, and my print points function can be called just with a starting pointer, and it will print out by going through the list the components of these points. Now I want to change this a little bit more. Instead of having to keep track of what is being linked to what. I want to only keep track of what's the end of my list. Initially, my list consists only of PT1. So the start and the end of my list are both PT1. I'm going to edit this and create a new pointer that points to the current end of the list. Initially, the start and the end of the list are all the same. Remember, when you put several equal signs, several assignment statements onto one line, they're evaluated right to left. So we take the address of PT1 and assign it to end. Then that is taken, which is still the address of PT1, and assigned to start. So all three elements have the same pointer stored in them. Then I simply want to append to my current end PT2. The only trouble is I need to update my current end. So we need to figure out how to do that. Update end. So kind of like here. Update end. Because I have appended a new point to my list. And finally, I want to append to the new end the address of PT3. And then I need to update my end. And there are several ways to do so. One way to update the end would be simply to say, well, my new end is the previous end, but I added something into it, so it's the next component of the previous end. That's a little cumbersome. It would be nicer to simply return the new end via the append function. So we're going to do that. So we need to modify the append function so that it returns the new end of the list. Currently it doesn't return anything, so we're going to change the return type of the append function and have it return a pointer. Point star, and now we need a return statement. What is the new return point of this list? Well, it is my new point, or end next, as we did before, just to make things a little bit cleaner. So we return that in the function itself and then capture that up here with my new end. So now we have updated end. We don't need to do it every time up here. It happens automatically down in the append function. So let's run this again. Oh, we need to update the prototype as well. Otherwise, you're going to be in trouble if we don't update that. There we go. Okay, compile and run. My points are declared. 2 pointers, start and end, are declared. Let's watch them. They both get the address of PT1 written into them. And now append is called. So append gets the current end, FFF4, and the new point, FFE8, the address of the new point, and it does its thing. So end next is new point. So it now wrote into PT1.next the address of PT2. Let's go back over here. And now it returns end next. So the next component of the point that end is pointing to PT1. So it's going to return the address of PT2. And that address is going to be stored in end. So the end of the main function is going to be updated. There you see it, FFE8. The list no longer ends where it starts. It ends at a different point. It has a different point at its end. So it starts at FFF4, which is the address of PT1, and it ends at FFE8, which is the address of PT2. Now we call append again, and we link the points together, and we return the new end and capture that up here. So now the end is FFDC, which is the address of PT3. So the list starts at PT1 and ends at PT3. And now we could call this over and over again. So the reason we just did that is so that we can make our program more general. Print all these values out, and we're done. The reason we just went through this trouble of changing how we link our lists together is that this style lends itself more toward arbitrary numbers of points. We don't have to be restricted to 3 points. So next, instead of declaring 3 points here at the beginning of the program, we're going to use the malloc function to get space for our points, and we can then call the append function as many times as the user wishes to, and we're no longer limited to these 3 points right here.